Let's see if we can gain some more intuition about how water flows below ground and how hydraulic head works. So let's consider another experiment. We've got some lab bench here. This is our datum. This is the elevation to which we're going to be referencing things. And we have another Darcy tube. And in this Darcy tube, again, we're going to have these little points where we can measure with another tube the level of the water in here. These other tubes are called manometers, by the way. They're open at the top. So they're just stuck here into the tube. And let's say that the level of water in these tubes was the following. In this one, it's up here. This is all full. And in this one, it's right here. So it's higher over here than over here. I'm going to ask you, which way is the water flowing? And let's do a little bit more analysis here. So when we first were introduced to these Darcy tubes, we learned that this is the head. It's this total height here of the water in these manometers. This is H1 and H2. So H is the hydraulic head. But we can decompose this head into a couple different components. It's going all the way down here. The first component is the point at which it's being measured, which is the entrance of this tube right here. This is the elevation component of head, denoted Z or Z. So this is the elevation head here. And then this height that the water rises to above the point of measurement is known as the pressure head. And it's denoted with this Greek letter psi, psi1, psi2. It's kind of like a pitchfork symbol. Okay, returning to our question, which way is the water flowing? Well, if you answered from left to right, you would be correct. This is the direction of flow. And the reason is that water flows down head gradients from area of high head to low head. And it flows down the total head gradient. And the hydraulic head is the sum of the pressure head and the elevation head at any particular point. And so even though it's flowing uphill relative to the elevation head, with respect to the total head, which is the sum of the pressure head and the elevation head, it's flowing downhill. So H is equal to psi plus Z or Z. So what is this term H anyways? This hydraulic head is a measure of the fluid's potential. And you may have come across this term potential in your physics class before, and it's very similar, and we'll talk more about it. Potential. It's a slightly different definition, but H is a measure of the potential. We'll talk about this more. I do want to just illustrate another idea here, and that is that suppose we had this vertical tube here. We have a manometer at the top and a manometer here at the bottom. Let's say the pressure head was the same in both of these, so the water rose to the same amount. This elevation head up here is still higher. And so we know that flow is possible due to elevation alone. So there's no difference in the pressure head components between here. If we were to turn this thing on its side and consider this case, we've got a manometer here and its water levels up here, and we have another manometer here and its water levels right here, let's say. Here, there's no difference in elevation head, but there is a difference in the pressure head. And so we know, again, that flow is possible due to pressure alone. So either one of these acting alone is sufficient to cause flow, or the two together can cause flow, and the sum of their terms is what we need to think about. So we'll talk more about these in the coming videos as well.